All right, so this is a respiration sensor, and the way this works is before you sit down, we're going to put this on. So you just hold this, and then you're just going to put this around behind you, and let's see if it might need to be a little bit tighter. Let me just adjust it here for you. So we're just going to tighten this a little bit, because this needs to be relatively snug. Did you snap it in already? Mm-hmm. Okay. How's that feel?
Sweater for bear.
Yeah, that's fine. Just a tiny bit tighter. Okay, that feel okay? All right. So just, is it right about where your belly button is? Okay. So you can have a seat. So that's going to measure the breathing. And what happens is when he inhales, unless he's doing this, then the belt is going to stretch some, and that's going to show us an indication of the inhale. And then when he exhales, then it'll go back to normal. So what we should see is a line that goes on the screen up when he inhales, down when he exhales. And part of what we're able to show people is if they're breathing up in their shoulders and chest, that they are doing that, and if we're trying to teach them abdominal breathing or diaphragmatic breathing, then that's a way to show them. So this I've just put on his hand. You can just put your hand up so they can see. This is a plethysmograph sensor. So instead of going on the ear, now we're going on the finger with this one. All right. So this is a screen that is going to show two different signals. So over here. Where's the, oh, here's the clicker. Okay, so over here we've got the blue is the breathing, and the pink or red is the heart rate. So you can kind of see the relationship that Jack was talking about. Here, they're both going up and down, but they're not quite in sync. They're getting closer, but the more you would practice with doing the breathing, the more you would probably see that they start to synchronize. Can you see that okay? All right, so I'm going to let him just work on that for a little while. But this is part of the difference is where when we were looking at the other screen, we were just seeing the red line. So that was just heart rate. Here we're seeing one signal for the heart rate and another for the breathing. And so that, depending, I don't know, with some of all of these experts in heart rate variability, that you've spoken to and worked with and all, some of them probably feel like it's more important to have a signal for the breathing than others do?
The way that I think about it, and at least some people agree, is that for research, the respiration is pretty crucial. But just for clinical biofeedback training, you don't have to have it. As long as they can get good variability and get the amplitude and get the period good, without respiration, then you've done something clinically as far as the intervention goes.
Right. Okay. And now, remember in the earlier, this is probably the first part when Jack was going through the different frequencies, the very low frequency, and high frequency. So these would be an indicator for those measured, very low frequency, and high frequency. This particular display doesn't have the 3D spectral display, but on some of the other screens you might have that. And so the way that they have this set up, the goal would be to have this middle bar going up, indicating the low frequency increasing, and these two, the very low frequency and high frequency, going down.
Right.
Some screens are going to have more information and others will have less. So sometimes,
and that's because the 0.1 falls in the low frequency is the reason why for that. So your respiration is moved out of high frequency into the low frequency range, and now it's being resonated with the barrel reflex, and that's all around the 0.1. So you're doing excellently here. You're doing fabulously about that.
And you see how there's times when it's matching more than other times. So a lot of times I will have them watching that and just letting them know that the more in sync they are, the better. This is the pacer here, and you can adjust the pacer. Right now it's set at 6 breaths a minute, So if he's following that, then he should be doing pretty well. The other thing I will show the person is that this is tracking the actual breaths per minute as recorded. That's some extra feedback. This light turned green and all these are yellow. That means that at that moment, during that time, the very low frequency and high frequency are going down and the low frequency is going up. So that's like considered the most ideal state. And again, going back to what we were talking about before, we would want the person to kind of notice internally what they feel when that's happening. So that goes to what you were asking about before. And the more they practice and the more they're in tune with their body, they can start to notice what that feeling is. And there's times when you'll go into that mode for just a second, and then you kind of slip back out. And then there's other times when you stay in it for 5 seconds, 10 seconds.
Like for example, when the little, what do they call it, the sand thing on your computer is spinning around while it's doing something, that's a great time to do some of this.
Right.
You know.
And that's a good point. Sometimes we want people to practice something X amount of minutes, per day and that kind of thing. I try to get people to practice at odd times that it's not like a set aside time. So if you're standing in line at the bank or the post office or you're in the car at a red light and you're waiting for it to turn green, those are like really short amounts of time you can practice, and then you go back to doing whatever it is you were doing. So that way, kind of like what was going on in your workshop earlier, it's like some of it is you're building it into just what you do all the time.
That's right.
And I think that's the most helpful. So I wanted to just show you that. So there's various systems that allow you to do heart rate variability.
And I think you get a round of applause for your performance here.
How do you feel? This was your question too. So now, could you notice anything different when you were doing better versus when not? The signal wasn't as synchronized?
Not yet, to be honest. At this point, I'm focusing on to actually make it happen. So I'm cognitively very involved to make it happen the right way. So I can't concentrate on anything pleasant.
It's only a few minutes.
Yeah, I'm just like trying to make it synchronize as much as possible.
Right.
I notice that if I breathe with my chest, it affects it negatively. If I breathe with my stomach, it affects it generally positive. You told me about breathing with the timer. I think this is when the music started playing.
Mm-hmm.
So.
And that's because that's probably partly because you were at that 6 breaths per minute. And there's something that Jack mentioned earlier that you might do. Some people do it and some people don't. But what you can do is you can have that pacer set. You can do an assessment at the beginning. So you might have the person breathe at, in some cases, let's say 4 breaths a minute, 4.5 breaths a minute, 5 breaths a minute, and up to, let's say, 7 or 8 maybe. And you measure what the heart rate variability was at those different rates, and that can sort of figure out what would be most ideal for them, and that's according to the way that some people do it. So this is again, this is another system. There's a bunch of different systems that we can use to do heart rate variability, and part of what I'm going to do next is kind of go through some of. And by the way, this is a lot of the statistics that you can get. So it's like we're only looking at 2 sensors, but there's a whole bunch of numbers that you can get from that. And we talked about the heart rate, of course. There's the you just press on that there. There's the interbeat interval. There's the SDNN, and there's plenty of numbers that you can look at. Thank you. And you did a great job.
Good job.
One of the things that happens paradoxically is people get performance anxiety trying to do the coherence, and that really gets in the way.
Let's see, back up here. Okay. So these are some of the things that we want to think about when we're looking at the type of equipment. There's a bunch of different choices for equipment, and some of the things that can be important about making the choice of what equipment that you're going to get. So there's things like signal quality. It was even mentioned that you can kind of use the camera on the cell phones with one of the apps to get some measures of heart rate variability, but it's not very accurate. And that wasn't designed for that, and that's an issue. But for the purpose to just get somebody to do a little practice, and it's better than not having it. The type of sensor, so there's the type that goes on the ear. The question came up as far as, well, what if somebody has a lot of earrings, and you run into people that have 6, 7 earrings on one ear? Well, it would be much easier to use a finger sensor for them. So if you have a system that only has the ear sensor, that may be an issue if you work with people that wear earrings. The types of signals that are recorded. So we've looked at a system that just has the heart rate, and now we've looked at a system that has the heart rate and the respiration. So that can be important. Another reason, besides being able to actually see both signals together and see how synchronized they are, another reason for using the respiration sensor is when people want to teach breathing where the person is actually doing the work here rather than up here. The respiration sensor can be very helpful. You can have a person that says, I am breathing with my belly, and they keep doing this, and you can tell them 100 times, or you can show them on the screen. And if the line is not moving, they're probably not doing what they're supposed to do. The feedback interface. So you can see on some of the screens it was just basic lines, and then other screens had games. So those are some of the different ways that you can look at the data, and also there's the graph that will actually show the frequencies. So that can be important for some people and some purposes, and if not, then one of the other screens that doesn't show it just shows if you're doing well, can be useful. The types of data that you can get. So for training purposes, some of the detailed data may not be necessary. Just being able to see, am I doing well or not, is the important thing. But if you're doing research, there's certain data that you want to see. Jack and I were talking earlier, and one of the things that's important for him is that he can see this IBI data. And you can have software that maybe can show you a nice screen to show if there's coherence, where they might say it's coherence, or a light turns green or doesn't turn green, but it may not have the data that would be necessary to do proper research, that type of thing. And of course, the cost can make a difference if you're going to do work with groups, and you got 20 people there that you have to hook up to something. Well, if you've got each piece of equipment costing thousands of dollars, that may not work. So you might need to have something that's lower cost to be able to work with multiple people, or to send something home with somebody. But then you might want to have other equipment that may cost more, that has features maybe that the lower cost equipment doesn't have, and that most likely would stay in your office, and people would come in to work with you on that. You have some devices that are self-contained that can just be used by themselves. That was one that I think, did you show it, or Jack? One of you showed one of the M-Wave 2 devices, and those are self-contained devices that don't need to connect to anything else. They can be used just by themselves, and they have a light bar and sound that lets you know how you're doing. Whereas other devices would need to either be connected to a computer or to a tablet or a phone to be used. So that's a consideration. There's a therapist that's at another VA that is deciding on which device he's going to use, and it was recommended to him to use the ones that connect to the phone, but then he was saying, some of his people don't have smartphones, and they still have a flip phone. Well, that's not going to work for this. So the self-contained devices would be better for him in that case. And also, how you're going to use it. Is it going to be used clinically for research or for home practice? So with the signal quality, you want to be mindful of that. When you're getting feedback, it's always good to remember that the feedback is based on a signal. And if the signal, whether you can see it or not, if the signal is lousy, if it's noisy, if it's full of noise, then your feedback that you're getting may not be that good. So like for instance, when you were looking at the system, or when you were hooked up and you were testing to see, okay, what happens when I hold my breath, you know, that kind of thing. So if you have a signal that is not accurate, it's not really recording properly what's coming from you, then it may not matter what you do, and you would be, you know, it'll be saying you're doing great. So that can be an issue as far as the quality of the sensor. And another thought about the types of sensors, sometimes using a sensor that goes on the finger, if a person has really poor circulation, it can be difficult to pick up the signal properly. And like on the screen we were looking at before where it had those red lines sometimes, that was because it was losing the signal. That can be based on movement, but it could also be based on not getting enough volume of blood in the fingers. So this is just showing, being able to see the actual recording, you can kind of detect if there's artifacts. Sometimes like this would be showing that there's a poor signal there. But if you don't have this graph, and let's say you just have a light that's turning green when you're doing well, it's less, you're less able to see whether there's a problem with the signal. So you have EKG sensors, and you also have the plethysmographs. We talked about that before. Most of the systems that are in use, I believe, are using the plethysmograph type sensors. There are some that use EKG, but I think in general people feel the plethysmograph sensors are just easier to work with. So these are some different things. This is the sensor we just used with you, measuring the heart rate activity. This is a form of EKG sensors. They're using a wrist-to-wrist placement. This is a plethysmograph that is connected to a tablet, and this is from the same company of the original software that we looked at, the HeartMath. And so you have similar software. It's not exactly the same because it's an app and not a computer program, but it gives you similar information on the tablet, or it could be on a smartphone. So they'd have to have the sensor that connects to the earlobe, and then in this model it's wired and it plugs in. But there's also a Bluetooth version of it that will work with either Apple or Android devices. And with the EKG sensors, sometimes we would use this type of placement, or you can use the wrist-to-wrist like that. And some of the smartwatches are now coming with EKG type sensors on them. We're not really sure about the apps that they come with and how useful they're going to be with biofeedback, at least for now. So the type of signal that's recorded, again, you know, with some of them you're just getting the heart rate activity. With other ones that have both the heart rate sensor and the respiration, you can get both signals. Then you have the type of, I didn't know that was going to move. You have the type of display. So you got some displays like this is what we were just looking at. You have other displays that would look like this. So here you have your spectral display where you can see if the signal is at 0.1 or so on. You have your other types of displays here, spectral displays and so on. And with some of them, you have, you know, games for your feedback. So when you're doing well, then you have a character that does something, or something like that. I was also working with one of the other ones that you can plug in this driving game called Dual Driver. So you're driving through all sorts of scenery, and you start to slow down if your coherence is lower. And so you could be hitting the go, but nothing's going to happen because your coherence is too low. Once your coherence gets better, then you start to move again. So those are some of the types of displays you can use. We didn't do the balloon game or the rainbow game, but those are also on this same software we were looking at earlier. This is what the feedback looks like on that self-contained device. where you've got the lights that indicate whether you're in coherence or not, and then it also has some sound with it. And this is another pacer display that comes with one of the software programs. This is the dual driver game that I was talking about. And here, you know, if you've got this type of display, again, you can see when the coherence changes. This would be respiration and heart rate there. And this is the 0.1 area on the spectral graph that we were talking about. So it can, depending on what you're looking for, or you know, what you think is going to work well with the clients that you're working with, there are some choices to be made as far as the type of software that you would have. And then the types of reports that are available. So with some of the software, you might have just a couple of data points that you can get from the software, and then others may have more detailed data that would be available. So this is one of the reports that one of the systems puts out. And it's relatively simple, and it has certain things that you can just point out and look at, and you know, so the person knows, did I do
What
better or not?
That one's, what is that one?
I think this one is from the HeartMath, the newer, what is it? The Plus Pro. Yeah, I think it's the Plus.
Pro.
Yeah.
I mean, that's nice.
Yeah, and then there's the cost. You know, so you have what I would consider home devices. Those are going to usually be in that range. When you get to the more professional systems, those are going to be more in this range, depending on how many channels they are and what software it comes with and that kind of thing. The system that I was showing there actually has 8 channels, but most of the other stuff is for measuring other things. We didn't get into other things that you can measure, but you know, we measure things like surface EMG for muscle activity, skin temperature, sweat activity. We've been dealing here with heart rate and respiration, but then you can also get into EEG as well. So these are some of the devices that would be more considered home devices. You've got like the HeartMath. This is one that connects to the computer like we just showed you. This is the self-contained device. This is the one that connects to a smartphone or a tablet. This is another device made by a company called J&J that you can measure other things like surface EMG and temperature and so on, but it does a decent job of the heart rate variability, and there's other add-on software that you can use with it too. This is another system that's pretty much related to the system I was just showing you, by a company called Thought Technology. And there are others, I can't name all of them. So you have how you're going to be using it. Are you using it for home, for practice, for groups, and so on? The cost, you know, if you, depending on your budget, what is going to make sense. The type of feedback interface, the kinds of screens that how it's going to show you the information for feedback purposes, the type of sensor. So those are a lot of the things that we talked about as far as, you know, how you would decide what equipment you're going to use. And then the convenience, you know, if you need to be able to just be out and about with it, the self-contained unit might be the best. If you are doing other things, then, you know, system like what we showed you here might be better. So again, with the clinical research level, you have you know, things like the type of sensor, the signal quality, what signals are recorded, and so on. These are some of the more what I would consider clinical grade or professional. There's one of the companies is Thought Technology, another one is Nexus, and these are some of the screens that they would use. Okay, so real quick, the training. So there is a certification that's available in biofeedback, and there's different certifications, biofeedback in general for peripheral biofeedback, which would be like your surface EMG, skin temperature, skin conductance, respiration, heart rate. Then there's a neurofeedback certification, which is specifically for brainwave, and then there's a heart rate variability certification. Now, there's not a law that says you have to be BCIA certified. It's something that's strongly recommended, but there's not a law. And to use biofeedback professionally, it's more important that it falls under your scope of practice to use biofeedback, and that you have a license that allows you to do whatever you're doing. So if you're not supposed to be treating headaches, then you really shouldn't be using biofeedback to treat headaches either. It's under the scope of practice that's the important thing. So they do have the BCIA is the sort of standard for certification that's available, and the website is bcia.org. They have all of their certification requirements there. One of the main things is that you go through a training program. For the heart rate variability, they have a 15-hour training requirement, and they would have on the website organizations that do training for that. It describes the certification program, what's required. There's a test also that they give, and it shows. I know you can't see this from there, but you can get the slides. And also, if you go to the website, you can see all the details. So they have, for instance, heart rate variability, anatomy and physiology, 3 hours, biofeedback strategies, 3 hours, heart rate variability applications. So it kind of just shows the areas and the number of hours that you need to go through the training for. So whether a person is getting certified or not, I would still recommend that you go through a training program that would meet the requirements for the certification. This is another website, AAPB. That's so BCIA stands for Biofeedback Certification International Alliance, and then AAPB is sort of a sister organization that is more membership and education, and they have their own website, and that's the Association for Applied Psychophysiology and Biofeedback. They have events listed there on their website, which would include training programs. I also do training programs and would be listed on the BCIA site and AAPB as well for the programs that we do. There's also state and regional chapters of the AAPB. So they have an annual conference. Maybe you're not going to go to their annual conference, but there may be a conference that's more local to you. So on their site, they have a list of state chapters. So there's a California, Florida, Texas, and Mid-Atlantic, and so on. And so you may be able to find one of those groups that also does conferences, and they may also have some workshops that they're doing locally as well. The main things is that you go through a training program. For the heart rate variability, they have a 15-hour training requirement, and they would have on the website organizations that do training for that. It describes the certification program, what's required. There's a test also that they give, and it shows. I know you can't see this from there, but you can get the slides. And also, if you go to the website, you can see all the details. So they have, for instance, heart rate variability, anatomy and physiology, 3 hours, biofeedback strategies, 3 hours, heart rate variability applications. So it kind of just shows the areas and the number of hours that you need to go through the training for. So whether a person is getting certified or not, I would still recommend that you go through a training program that would meet the requirements for the certification. This is another website, AAPB. That's so BCIA stands for Biofeedback Certification International Alliance, and then AAPB is sort of a sister organization that is more membership and education, and they have their own website, and that's the Association for Applied Psychophysiology and Biofeedback. They have events listed there on their website, which would include training programs. I also do training programs and would be listed on the BCIA site and AAPB as well for the programs that we do. There's also state and regional chapters of the AAPB. So they have an annual conference. Maybe you're not going to go to their annual conference, but there may be a conference that's more local to you. So on their site, they have a list of state chapters. So there's a California, Florida, Texas, and Mid-Atlantic, and so on. And so you may be able to find one of those groups that also does conferences, and they may also have some workshops that they're doing locally as well. This is a book that I'd recommend, Foundations of Heart Rate Variability Biofeedback. That's available from the AAPB. And I think that is it. So I'm sorry I didn't get a chance to show you some of the other specific systems and instruments, but there are a bunch of other ones. But a lot of it, you know, there's some of the smaller ones that connect to the phones and tablets and so on. But there's, you know, if you wanted more information, I'd be happy to talk to you offline about some of that. And thank you for your attention. Very good.